Oh, this is JEM W4JBM. I'm going to do a video a little different from most of mine. Everybody seems to like a good teardown video, so we're gonna try that today. Recently, I've been working on a membership card, ELF membership card. It's based on the 1802 microprocessor, and this is it's something that interested me. This is the issue of Popular Electronics, August 1976, where they first described the Cosmic ELF and how to build it. I have wanted to build one since 1976. This kind of fulfilled that urge, but I'd still like to build one from scratch on maybe a wire wrap board or something like that. But one thing I wanted to share, this goes back years ago. I started work. I work in the utility industry, and one of my first jobs was as a SCADA systems engineer and a project manager on upgrading some SCADA systems. I later left and went to work for another company where I was a SCADA systems engineer for a while, progressed through a couple of different roles, and ended up running the meter shop for them. A guy from the company I originally had worked for called me one day, and he said, I know that you guys, this would have been around probably 92, 93, so I know you guys have some of the JEM meters that you're retiring, so I wonder if I could get those, and we're running short of spare parts, and parts are getting hard to find, and so I'd like to get some of the ones you're scrapping if I can to use for spare parts. Unfortunately, we'd already pulled ours and scrapped them, sent them off for recycling, and I didn't have any, but I reached out to some peers around different companies, and I found one at another utility that he said, yeah, we just retired our JEM meters. They're sitting in a couple boxes out in the warehouse. How much do you want? So I told him, the guy had asked for if he could just get 2, 3, 4 meters, he'd be good. So a couple weeks later, I got a couple of boxes, and there were 2 boxes with, or actually 4 boxes with complete meters in them. And there were, I believe, 4 other boxes that just had the cards that I'm going to talk about here in a little bit pulled out and stacked in them, probably from another 6, 7, 8 meters between all the different cards that were in those boxes. So I was sorting things, getting ready to ship it off to the guy who had originally asked me for it, when I realized or noticed that one of the cards had an 1802 microprocessor on it. And I thought, all right, this is it. I've got the beginnings of building my own 1802 computer from scratch. So that was, like I said, probably 1993, 94. It is now 2017, and I still have not built my own from scratch. So that it's still on my list to do. And digging around, I came across one of these meters. I want to talk a little bit about it. So this is an electric meter. This is larger than what you'd find on your house. These were the JEM meters. This is actually a JEM 2 version. They were made by, I believe it's Rochester Instruments, and then Scientific Columbus bought them out. But they were often used at what are called revenue metering points or interchange points. So most of the electric grid is interconnected. Utilities connect to other utilities. And when you do that, it greatly improves the reliability, but you also need to keep track of how much power is flowing through those tie points. If I'm in theory not buying any electricity from anybody else, and I've got 100 interchange points, then when I sum up what's going out and what's coming in at those 100 interchange points, in theory it should sum to 0. If I'm buying 200 megawatt hours for the 10 o'clock hour or something like that, then they should all sum the 200 kilowatt or megawatt hours. So these were used for high accuracy metering, also where you needed to have a record kind of hour by hour of what had been consumed each hour. A lot of the readings were brought back over a SCADA system, and a lot of times that came from a different device. and then the actual revenue meters were used to true up. They were much more precise, and at the end of the months, you might have a little bit off one way or the other, and you could true everything up. This is a three-phase meter. Obviously, most of the interchange points, well, I guess it's not obvious if you're not a utility person maybe, but most of the interchange points are three-phase meters. There was a version of this that fit into a rack mount device that basically had a round hole in the front and this meter with a special socket in the back. And this is not something you'd find typically in just a meter socket sitting outside even a home or a business, although some larger businesses, they might use something like this. It's called a transformer rated meter, the meter that's on your house. There's no instrument transformer to step down the voltage or current. If you have a traditional electromechanical meter, these operated at voltages of maybe 13.8 kV or something like that, and currents much higher. So a lot of times there's what are called instrument transformers, which are voltage transformers and current transformers that step it down, and the normal values to step it down to is something that's normalized around 120 volts and normalized around 5 amps, and then you can use correction multipliers to scale the values inside the meter, so the meter is actually giving you an accurate reading, taking into account the instrument transformers that are connected to it. So anyway, that's probably more than you ever wanted to know about metering. I have on this one, there's a pair of just RF shielding plates that they go inside it. They are they're very temperamental to get out. So I've gone ahead and pulled those out. Typically there's going to be a seal on the cover so that you can't do this without breaking a seal, but or maybe I can't do it at all anyway. But the cover comes off just twisting and turning to the side. When you do that, there's a series of cards in here, and there's actually a motherboard down here on the bottom that's got the main bus on it. So we're going to walk through the different cards here and just kind of see what we've got and what might be the good basis for something like an 1802 microprocessor build. So I'm going to start off, this yellow one says CPU, and if we pull this out, this actually has, this is the 1802 microprocessor. I've got some cheat sheets here too, because I can't remember all of this without looking, but this is a 2.4588 megahertz crystal that's acting as the oscillator for that. These are 1855 chips, and there's a pair of them. These are actually external multiply divide chips. So they instead of having to go through the instructions to do multiplies and divides at the speed that the processor could do it, the processor could actually offload that into these. So basically, kind of like an early math coprocessor that lets you do some of the math that's necessary in the power calculations. If you want to know how many watts you've got flowing, watts or power is equal to current times voltage, and you got to correct for any phase difference between the current and voltage also. But multiplication is something you would do a lot of, and so they look for ways to do it much faster. Then these are the two EEPROMs that are providing some of the programming for this. We'll run into some other EEPROMs as we go further. And then they're also in this lower corner here a pair of 6514s, and the 6514s are actually 1K by 4-bit memory chips, and so this is between the two of these, that means there's 1K of memory on this. I'm not sure what size the EEPROMs are, but that's the ROM or EEPROM that's associated with the processor card itself. Just kind of randomly picking a direction. Here's the options card. So this one's actually, it's like a memory expansion card, and it's got a pair of EEPROMs in it. I'm not sure, again, what size they are, although I can make an educated guess that they are 2K. This is a 6116 memory chip, and that is 2K by 8 bits. That's why I assume that these are probably 2716 EPROMs, also 2K. So you got a total of 2, 4, 6, 8, 10 times 2. So this could be 20K of either RAM or EPROM, depending on how you populated it. So there's also a power supply board in here. There's a connector here I'm going to undo. That brings some of the voltages in. Rectifiers, capacitors, 7915, so negative 15 volt regulator. Let's see, this is a ULM 2077. I'm not sure what all that is in terms of, I don't know if that's just a transistor, if that's a small regulator, or maybe, yeah, that's a 2N something, so another transistor there. So basically, at least part of the power supply. Obviously, there's some other parts to the power supply in terms of transformers. This is going around to some of the transformers. And somehow that's being pulled off, and I'm not sure what the voltages are. One thing I really kick myself for, very proud of having snagged the meters, but unfortunately I should have grabbed a copy, just grabbed a copy of the meter manual that had the schematic. I've been able to find a copy of the manual itself online, but have not been able to find a copy of the schematic. So this last card towards the back is called the comms card. And this is one of the great disappointments. It says note special unit, components have been removed from this board, serial communications are not possible. And actually this over here says components have been removed from the communications board, serial communications are not possible. So there's probably something like a UART down here at some point, or it was capable of it. There was never one in this unit though. So I don't have what would be needed for traditional serial communications, although even like the membership card implements serial communications without using a UART. Moving back forward from the CPU, there is it's labeled clock, and this has let's see which one it is. It's this one here. This is a MSM 5832, and this is a real-time clock. You can see that they've probably done some kind of calibration on the oscillator that drives that clock, and then they've sealed it with something. But this is it's designed to be connected to the bus of a computer and used as a real-time clock. So a one-chip real-time clock, kind of interesting to have. There's an analog to digital converter card. This, there's again some PROM or EPROM up here, but at the guts, this is an 8031 chip from Intel. So the 8051 series is actually a very popular series of microcontrollers and used pretty widely. The 8031 is similar, except it does not have any internal PROM. So typically on the 8051 you can actually program it, and the program resides inside the chip. This needs the external program. There's some scratch pad memory. I can't remember for sure how much it is. I think it's either 128 bytes or 256 bytes of scratch memory in here for doing things. 12 megahertz crystal. I'm not sure if that's being divided down. I assume it is to clock the processor, and then I won't even try to make guesses about what most of this, the rest of this is in terms of doing the analog to digital conversion. But obviously that's kind of the guts of things in a way. This is what's taking the voltage and current that's coming into this meter and converting it into something, converting it into binary numbers in effect that can be processed by the microprocessor itself. So the last card here towards the front is the memory card. These are a little difficult sometimes to get out if the LEDs have worked their way forward. This has an Intersil 7218 chip on it, which is a driver for 8 7-segment LEDs. This is a switch that can be used like that way, the temporary way, resets the peak demand reading and basically restarts counting the peak demand. The other way is marked as time set, so would let you set the real-time clock inside the meter. You can see the bus down there. There's a couple other odds and ends. I believe there's an EEPROM that's hidden up in there. I'm not sure what this other chip down in here, but you know, that's pretty much the goodies. There are a couple other. There are the transformers, and there's some stuff on the bottom here I think have to do with some of the analog to digital calibration. But this is I don't know exactly when this was introduced. I believe in the early 1980s sometimes was the JEM 1. JEM stood originally for Joule Electronic Meter. I believe Joule is a measure of energy, so it's kind of a pun. There's information here about the multiplier. So the voltage transformer ratio was a 20-to-1. So when this was measuring 120 volts, the actual voltage that was on the step-down transformer, instrument transformer, would have been 20 times that, or 2,400 volts. The current reading, there was actually a CT, current transformer, that was 200 to 5. So when this was seeing 5 amps, there was actually 200 amps on the flowing through the core of the instrument or the current transformer. Then there's some other information about the constants for the meter. A lot of this goes back to the days when there were actually discs, or there was some thermal based demand meters also. But you know, they went to a lot of trouble to make this look like a traditional meter in terms of the readings you get off of it, because at the time, well, even today, there's something like in the old days it would have been a billing system, or something like this would have been in the power counting system. Today there's things called meter data management systems, MDMSs, that everything has to fit into. So there's kind of a consistent format that you need everything to work back towards. But that is the guts of the JEM 2 electronic meter, one of the early electronic meters. Probably was not the first, but it was, so far as I know, this was the first widely accepted digital meter. It was used in the revenue metering, like I mentioned, which is a very critical application. So you know, utilities had a lot of confidence in these meters. It says it's copyright 1981. So this is it's kind of an interesting little piece of history. I may pull a couple of the chips off of this to use. I could see maybe using the 1802, obviously. I doubt I would go to the trouble with the 1855 multiply divide chips. That probably isn't worth the trouble for anything I'm going to do. But with the 6116, that's 2K of RAM. I may use that, although these days for I actually just bought a 32K, well, 5 32K memory RAM chips for it was $5 plus $5 shipping, so $2 each. So it's kind of hard not to rationalize putting in 32K of RAM if you're building something from scratch. The real-time clock is interesting, although again, for most of what I'm probably going to do with an 1802, you know, it's going to be something I'm going to tinker with, but not something I'm going to. I don't see using it on a daily basis. I probably won't go to the trouble of implementing a real-time clock. Actually, the 8031 is kind of interesting. I've kind of wanted to play around with the Intel 8051 at times. So maybe this is a start towards doing that. The LED displays, I don't really know that there's a whole lot there. And like I said, I'm kind of disappointed that there was no UART. Serial terminals, having the switches on the front panel is definitely, it's cute, but it gets old after a while. So having a serial port makes a big difference. So probably what I'll do is build something that's kind of modeled around this, so I can run software I write for one of the machines on the other. But anyway, that's before I get started. just typically when I do something like this, it's nice these are socketed, because I'll just pull them out of the socket. A lot of times I'll leave a note on it or inside the case that just says what chip I pulled and maybe what project I used it on, just in case I ever wanted to put this back together again. But little piece of history. Hope you enjoyed it. Likes and subscribes are always appreciated, and I hope you have a great day. Thanks. Bye.